Today we'll discuss about Cuckoo Search Algorithm. In case of CS algorithm or Cuckoo Search algorithm, this algorithm mainly mimics or follows the way the subspecies of cuckoo lay its eggs on a nest of other species. Like for example, in India, we have often seen that cuckoo lays its eggs in the nest of crow. So this very behavior of cuckoo is known as obligate brood parasitic strategy. This is not observed in all the species of cuckoo, but in some species of cuckoo only. But this is a very interesting strategy where what happens is the cuckoo bird lays its egg into the nest of other species, say for example crow. And what it does is that this egg has the capability to become very similar with the host egg. Why it does that? It does that because it wants to avoid detection. Correct? So the eggs of cuckoo is often adapted based on the species with which it is trying to lay its egg. And also what it does, cuckoo species, the eggs of cuckoo species hatch earlier to its host species. And once it hatches, the instinct of that baby cuckoo is it will destroy the egg destroy the egg of the host species by throwing them out of the nest, such that he only can sustain other eggs of the host species cannot. So this is the way where you see survival of the fittest, the law of Darwinism. This is a very good example of survival of the fittest. As cuckoo egg hatches first, so the hatchlings of cuckoo is there earlier to the hatchlings of the host species. So what happens is it destroys the eggs of the host species, and by chance, if the eggs of the host species are also hatched, so what the hatchling of the cuckoo will do is it will try to kill the other hatchlings first. That is its instinct. You cannot blame it, because it is based on its instinct. And you'll be amazed to know that the eggs of cuckoo often gets adapted so much that you cannot distinguish between the egg of the host species and the cuckoo. So if we cannot differentiate, the host bird also cannot differentiate. So it rears the hatchlings of the cuckoo, or it helps in hatching of the cuckoo eggs, and ultimately it helps the host species. In case of India, we see crow. Most often crow helps to hatch or nurture the cuckoo offsprings. And cuckoo is successful in 75% of time. It can avoid detection, and more better offspring of cuckoo is being produced without any work from the mother of the cuckoo species. So what it does is it obligate, or you can say delegate, the work of nurturing, not only nurturing, hatching, nurturing, and all these activities related to the production of good offspring, it obligate or delegate that thing into a host species. Now, if you think this cuckoo egg as the solution or the optimal solution, then you can employ the procedure by which cuckoo lays egg in the nest of the host species to find the optimal solution of your optimization problem from multiple solutions that you may have. But it is, of course, it is a better heuristic algorithm, and it has a very good advantage because we have to estimate only one parameter. I will discuss why I am saying that. And also we have the advantage of using Levi distribution, which will mimic the Levi flights of the cuckoo species. Now there is two type of path that a bird follows. One is random, another one is Levi. Now along with birds, some species of reptiles also follow this. In case of this Levi path, it considers or detects the species, first see where it stands, current position, and then what it does, it makes many small changes and occasionally large jumps. That means it employs a very adaptable and flexible path based on its observation of the target area. Suppose for cuckoo, its target area to find an optimal nest to lay its egg. So optimal nest of a species which it can easily mimic. So if you have observed crow and cuckoo, you will see these two species are nearly similar. This cuckoo is a little bit big and crow is a little bit small, but the color complexion and its search for food, everything is nearly similar. So what it does is it searches for a good crow nest and then lays its egg. So this type of search is an adaptive search. Because why I am saying it is adaptive? Because it targets the optimal nest. It doesn't use any random path where it randomly lays egg. No. It targets the best nest, suitable for its egg to be nurtured and first to be hatched, then to be nurtured, and which have a greater chance of generating healthy offsprings. So, in case of cuckoo behavior, this type of behavior of cuckoo is now mimicked for optimization algorithm. So the problem is like this: minimize y is equal to x square, subject to the constraint 0, x will vary in between 0 to 1, but it will not take the values of 0 to 1. And x will of course be into real number, he cannot take the imaginary number. This is what the problem is. Same problem as the other method I have described earlier. So here what will happen? There will be 3 steps. First step is A, second step is B, third step is C. So what are the assumptions? Firstly, I want to say that Young and Deb has proposed this algorithm. So as I was discussing that only one leg can be egg at a time in one nest, and also to maximize the egg survival rate, cuckoo will always lay its egg in the most suitable nest. Okay, and the most high quality eggs will be passed on for the host to nurture. That is the thing that cuckoo follows. And also you do another assumption, number of host nest is fixed. Actually what happens is we consider this nest as population. Okay. So first of all, say for example 5 random solution will generate. So 5 values of x will generate. And then we put into the equation, so it will give 5 different values of y. Now as we are trying to minimize this function, so the minimum value of y will be the optimal solution. So for the x, for the value of x, when y is minimum, that is the optimality or optimal point. So basically, as you know, that x is the desired variable and you can change x into anything to change y. You have no other variables. So this x is known as design variable. If there are multiple x, x1, x2, it is also known as design matrix. But you have to change anyway these design variables to change the y. Okay, so and the 3 assumption, as I've said, you can generate a finite number of nest, finite number of solution at a time, and you can lay one egg at a time only. That means each nest will have only one egg that can be laid by the cuckoo. And certainly to maximize the egg survival rate, the cuckoo will select and lay in the most suitable nest. Okay, and then lastly, this number of host nest is fixed. So you can, if you are generating 5, you can generate 5 only at a time. So you cannot exceed this value. Okay, so that is the number of, and also you cannot reduce this value because the number of population of the nest is fixed. That is the assumption it has. And yes, we will use the Levi flights, and also we'll use that thing that if the host bird can discover that alien egg. So here this is the alien egg, as you can see. And all these are the eggs of host bird. So if it can detect this, it will destroy this, and also it can abandon the nest. So that is why we also use this. If the nest is discovered, what will happen? This step is also there in the algorithm. Okay, so in this entire Cuckoo search algorithm, we have A operator, B operator to generate new value of x. We have A and B. Another C, this is where fitness function is compared, and if the new is better, that means new value is better than the earlier one, then we go for new one. So there is a strategy. Now what is the fitness function? Fitness function is nothing but the objective equation. So for two consecutive x, one at k plus 1 and another one is at yk, If yk plus 1 is less than, because this is a minimization problem, yk, then the solution at which this takes place, that is the value of x at which this takes place, will be your dv value. Now, how we can generate these new values of x? So the first thing is that you have to generate phi population. That means we assume that we have 5 nests, so we can lay 5 tags. So there are 5 number of x's initially. Note down that all these 5 values are randomly picked within the or from the feasibility domain. Feasibility domain means x 0 to 1, so this will be your feasibility domain. Okay, so the formula is that for the Levi flight or adaptive flight, because in case of most of the animal, insects or animal, they follow a random path while searching for food or searching for mate. They follow a random path. They do not follow any systematic path. But this algorithm or cuckoo follows a Levi type of flight. That means a flight which follows Levi's distribution. And inside this, there is a norm of gamma distribution. Anyway, let's see Levi distribution. How Levi distribution is mimicked now? This is the operator A or Levi distribution new location generated. What is the new location? New location is equals to old location plus C subscript I. Now what is C subscript I? It is 0.01 dot SI, this multiplication, and bracket EI minus E paste. So basically this CI is this one. In case of CI, 0.001 is given, unknown is SI, and this. So this can be done easily. This is the current position, okay, current position of x or current value of x. This is the best value of x, okay. Best means if there are multiple iterations conducted already, then among all this multiple iteration, for which value of x, y is minimum, that will be your best. And it is often also referred as global best. Okay. So this is E subscript I superscript k minus E superscript best. Okay, no problem. And what is this plus? Plus is actually, it's a very interesting concept where selection-wise multiplication takes place. But look, what happened is here that this SI continuously changes because SI is a function of U and V to the power 1 by beta square. Here beta actually is given 3 by 2. That is coming 1.5. And what about this V and U? This U and V follows a normal distribution pattern where 0 is mean, but this sigma U and sigma V is there. Sigma U and sigma V is there, and they say that so U and V, for the values of U and V, we have to use the normal distribution values of standard deviation for both U and V. So standard deviation or the sigma V is equals to 1 for this case. So no need to worry about sigma V. But you have to worry about sigma u, which is the gamma distribution of beta. And this gamma distribution of beta will come into, when you will calculate, it will come as 0.6966. And sigma b is 1. So basically what happened, this big N indicates the normal distribution. So normal distribution in between 0 and sigma b, this is 1. And normal distribution of this u, that is 0 and sigma u squared. So sigma u is this one, 0.6966. So basically what he is saying that normal distribution values of 0 to 0.6966 can be retained and used as the value of u. So this normal distribution of 0 and 0.6966, any random value we can take from this to value. This is actually the lower limit now and this is the upper limit. And also for v also the same thing, but here it is more definite, 0 to 1 random value, but normal distribution. And this is gamma u. I have already said this gamma u or gamma distribution of beta will give you a value of 0.6966. So now what happens is, for each iteration, mu u is given, because as you know, u is a randomly generated or follows a normal distribution pattern, but it is generating a new value at every iteration. So you will get the value of u, value of b and beta to find the value of Si or step size. This Si is also known as step size. So once you know what is step size, you put it here, and then this is the, I think this Eik minus E best. You have to collect it from the initial population that you have already generated. That is, you have already generated the 5 number of population. And what I found is that if you are not considering different values of x, the Ci will automatically starts to give yes, new value, but in different way. So Ci is equals to 0.01 multiplied by this Si multiplied by Ei minus E best. So that is what Ci is. Whereas again, where S is U by absolute V to the power 1 by beta. So I think for Si and Ci, no restriction is coming. And again, this U and V is going to be the normal distribution function of U and normal distribution function of V. So once you have generated this U and V, then you straight away put. Now, another things to notice. Here u is, or u can take any value in between 0 and 0.6966. And for v, any value in between 0 to 1. So this is what it is, and when you find the Ci value also, so what is happening here? First you will find the value of u, v, okay? Then you put uv to the 1 by beta. Beta is already known. So it is around 1.5 beta. So you get the Si for 2 random values and 1 different values. So then you go to this step and you find 0.01 into Si plus A. So all are used to find the Ci, and this Ci will be put here to find the Eik plus 1. Yes, so earlier we were discussing about the part A, where we have learned the main logic of GMDH and other numerical problems. So now what we are doing is I had gone through the first step, part A. Now part B is coming. Part B is coming, and yeah, then you can again sign a deal. But for now, part A and part B is missing. Part C is there. So let us without part B, let us assume that part B is there. So how to find the current position? Current position, or we famously say it as new position. So, okay. So so this is what is we are telling. This part of the expression is okay, and we know that this part can happen. So that is nothing but the current position plus random number, and then multiply it by this the at the kth iteration, d1 and d2. So generally what happens if you generated 5 different values initially, 1, 2, 3, 4, 5, and for both E we have generated that. Then what will happen here, you see ED1, so the first value and second value will be taken. Okay, so I think this is a good solution. And here this will be also a random function is there, EI plus random multiplied by ED1 minus ED2. This is it. This is what the operator P is, replacement of some nest by constructing new solution. So basically after part A we will have 1 EIK plus 1. Again after part B we have another, yeah. Correct. And please do not get confused, these are not new values, but the first value of the solution and the fifth value, but here in this case second value of the solution. So they are deducted, first value and second value is deducted from first value and multiplied with the random number, and then this entire expression is added to the table of PC. Okay, so this is the hierarchy you have to follow. Correct. So now what happens is the last part of this model. This model goes on like that. This part A, part B, and part C. So part A I have already discussed. Correct. Part B I also discussed, Levi distributed part. And now part C is the last one. How you select the best solution? Very easy. You have this one and this one, compares. If it is bigger than you, then also compares. If it is not, then also compare. So in this way, I think this will be done. But what I found is that many people is little confused how to select this. But okay, let me give the solution there also. If you are trying to compare e to the power k plus 1 and e to the power k, then what happens, k plus 1 is nothing but the next iteration and k is the current iteration. So in case of current iteration and future iteration, what will happen is that you'll also have a value of y, correct? Because these e, k plus 1s are actually a. Okay, so we'll have another y, which has a very simple design. Y is equal to x square. Nothing more, nothing less. Very good. So either the tourist will stay here. First thing is that they will compare ek plus 1 and ek. If ek plus 1 is greater than ek, then ek plus 1 wins. Otherwise, ek wins. Okay, so that is what written into this expression also, as you can see. So now that you have an idea, I will just show you the flow of the algorithm. So there is 3-step: operator A, operator B, and C. In case of operator A, you will get 1 ek plus 1, which will be equals to ek plus ci, and this ci will be a very complex term, so I am not going into it. Then it will also have a gamma distribution function. So the ci will be actually, let me see, 0.01 into random function. This is normal distribution, and then there is a sequential multiplication, but before that there will be step size, and then there will be a multiplication where the entire frame is responsible. ek plus 1 plus what I will say, ek plus 1 minus ek plus 1 global based. Okay, so this will be your ci more or less, and then ultimately we get ek plus 1. So this is one new solution, and this B will also give another new solution, right? But if the random number generated is less than the random number generated by new set. New says that you generate a random number, and yeah, so this step B also, what will happen is that I think there is also some formulas to solve to generate the new position, okay, new x or new ek plus 1, okay. So whatever may be the case, you remember that in case of A or in case of B also, initially at the time of initialization, we have generated 5 population of our E, correct? Now, if with that help of 5 population, we have generated already Y. 5 population means 5 different values of X. If you have already generated Y, then what you have to do is you have to rank the Y in the order of ascending order, okay. So when you arrange that ascending order, so for every value of D, you will get a new value of this one, new value of E, okay, and the value of D is often selected randomly. Okay, so if again this ek plus 1 is less than the probability of E, k plus 1, then everybody should have been saved. Okay, but it was not done, but the work is accomplished. So we will close here for now. This is a schematic diagram of the Cuckoo Search Algorithm, the flow path of Cuckoo Search Algorithm. So total, you have to remember 3 steps, A, B and C. One is A, followed by B and then C. So this is what you have to remember.